Hello, today we're going to stay in 6.2 and look at the definite integral. And we've actually kind of worked with this already on the past chapter and even in last night's homework. When I look at a definite integral, it is just an integral that has limits. Okay, and so we use the fundamental theorem of calculus that states if I integrate the function here, then it is equal to the antiderivative evaluated at the ending point minus the beginning point. So this is the ending value, and this is my starting value. All right, so it's the total change, the displacement that we have. Okay, so we are going to now, instead of using our calculator to do this, we're going to use this, we're going to figure this out by finding the antiderivatives of the functions. Okay, so here's my situation. I have the integral from 1 to 3 of 4x cubed dx. And again, I want to use the fundamental theorem of calculus that tells me if I integrate from a to b of f prime of x, it's just f of b, the antiderivative, minus f of a. Okay, so now you have to ask yourself, what function, when I take the derivative of it, gives me 4x cubed? And so you talk to yourself and say, well, that's going to be x to the fourth, from what we learned yesterday. And then remember, we want to evaluate it from 3 to 1. So we write that as our notation. And so I just do 3 to the fourth minus 1 to the fourth. Okay, so this is f of 3 minus f of 1. And that answer is just 3 to the fourth, which is 81, minus 1 to the fourth, which is 1. And so my answer is 80. All right. Let's look at another one. I'm integrating from 1 to 2 of x squared minus 5. So we can use the idea of our properties of integrals to split this up and say, okay, well, this is the same thing as the integral from 1 to 2 of x squared dx minus the integral from 1 to 2 of 5 dx. Okay, then you got to find the antiderivative of x squared. So which function, when you take the derivative of it, gives you x squared? So we know that it's going to be x cubed. So x cubed gives us x squared, but we don't have the 3 out there, so I have to multiply it by 1/3, because 1/3 times 3 results in nothing, or a 1, and then that becomes x squared. So I'm going to evaluate that from 2 to 1, and then I integrate 5. And remember, when we integrate a constant, our rule is that that just becomes 5x. And so we integrate that from 2 to 1, or sorry, we evaluate that from 2 to 1. So I have 1/3 times 2 cubed minus 1/3 times 1 minus, and I'd probably use parentheses here so that I don't forget to distribute my negative. So I have 5 times 2 minus 5 times 1. And so I have 8/3 minus 1/3 minus 10 plus 5. So I have 7/3 here. Minus 5. And if I wanted to put that together, this is the same thing as 15/3. And so I end up with a negative 8/3 as my answer. Okay, let's try another one. All right, so which function, when you take the derivative of it, gives you cosine? Okay, and that answer is sine, because the derivative of sine is cosine. I always just say that to myself once I write the antiderivative down. I say, okay, sine, okay, I'm good. especially with sine and cosine, because I can get off by a negative pretty quickly if I'm not really careful about that. So looking at sine evaluated from pi halves to 0, I write sine pi halves minus sine of 0, and this is where those exact values come back to get us. Sine of pi halves is the y value at pi halves, which is 1, and sine of 0 is 0, so the answer to this is just 1. All right, let's keep rolling here. All right, I can use another property of integrals that I've learned. I know that I can take that constant out and just integrate from 0 to 4 of e to the x dx, my absolute favorite function, because anytime I take the derivative of e to the x, I get e to the x, and anytime I integrate e to the x, I get e to the x. And so I evaluate e to the x at 4 and 0, so it's 2 times e to the 4 minus e to the 0, and e to the 0, please be careful that you don't put 0 there. E to the 0 is 1. And so you could write it that way, or 2e to the 4th minus 2. All right, now we got a cubic root. So it might help you to rewrite it as 1 to 8 of x to the 1/3 dx. And remember our rule when we're integrating. Basically, we add 1 to that. So it's 1/3 plus 1, which ends up being 4/3. And now we divide by that number, but we don't want to divide by a fraction. So instead, I'm going to multiply by 3/4. Now just in your head, double check. If I do the derivative of this, that means I'm going to take the 4/3 down times the 3/4. And 4/3 times 3/4 gives you 1. And then I reduce the 4/3 by 1. That gives me right back to the 1/3. So I am correct in my antiderivative. And then I'm going to evaluate it from 8 and 1. So I have 3/4, 8 to the 4/3. And then again, I'm going to use my brackets here so I don't forget to distribute later. And then 1 to the 4/3. And remember, when you're dealing with radicals, the power is on top. So this is my power. And this is my root. Roots grow in the ground. And so I take the cubic root of 8, which is 2. And then I go 2 to the 4th, which is 16. So I have 16, and 1 to any power is 1. So I have 3/4 times 15, which results in 45/4. All right, just a couple more here. All right, so then we have the 1 to e cubed of 1 over x. Okay, and some people put this in power form, but then I think it actually kind of confuses you, because if you write it as x to the -1 and you add 1 to that, you get x to the 0, and we get all kinds of issues with that. So we want to just try to remember which function, when I take the derivative of it, gives me 1 over x, and hopefully you're saying to yourself, oh, that's ln of x, and then remember we have to use absolute values to match up the domains there. And so then I'm going to evaluate that at e cubed and 1. This gives us an opportunity to practice our, well, e cubed is a positive number, so I really don't need the absolute values. So I'm just going to leave them off. And then I'm going to subtract ln of 1. Gives us some practice on our evaluating logs. ln of e, they basically cancel each other out, so ln of e cubed is just going to be 3. And ln of 1 is 0. So my answer is 3. All right, why don't you go ahead and stop this, see if you get it on your own. Again, you're trying to think of which function, when you take the derivative, gives you 1 over 1 plus x squared. And hopefully you're saying to yourself, oh, I remember that one. That one is arctan. All right, so arctan, and we're going to evaluate it at 1 and 0. So I do arctan of 1 minus arctan of 0. And you ask yourself, to figure out what arctan of 1 is, you say, okay, well, what function, when I take tan of it, gives me 1? And so that is pi fourths, because tangent of pi fourths is 1. And then arctan of what number gives me 0? And that is 0. All right, so your answer is just pi fourths. All right, last problem. And one thing I should mention before we even think about trying to integrate this, and I should have probably said it in the last two as well, but better late than never, you always need to make sure your limits of integration do not create any problems with your function. And so what I mean by that is I see a fraction right here as my integrand, and I know that I can never divide by 0. So I need to make sure 0 is not between 1 and e. And it's not, so we're good. And most of the time, you'll be good, but you just should always check, because if you get in the habit of just going forth and finding the antiderivative or integrating this function, and then plugging in your numbers, you'll get a number. But the problem is it's actually incorrect. And so you need to be really careful. So anytime you see a fraction or a square root or anything where your function's undefined, make sure your limits of integration, your function is fully defined on your limits of integration. All right, that being said, now let's tackle this problem. So I need to think of a function whose derivative gives me 1 plus x to the fourth over x. Uh-oh. I don't know anything that just gives me that. So then I think, okay, well, what can I do? I need to start thinking algebra tricks. So I'm going to go ahead and say, well, I can break this up. And I can write it as 1 over x plus x to the fourth over x dx. And then I can simplify that a little bit and break up my integral. So it's 1 over x dx, and then this becomes the integral of x to the fourth, or x to the fourth divided by x, which I would call x cubed. The limits still stay the same. And now I've taken a problem that looks fairly complicated and put it into two semi-easy integrals that we should know. All right, so I ask myself, the derivative of what function gives me 1 over x? And we say to ourselves, oh, that is ln of x. Remembering my absolute values. However, my absolute values aren't necessary in this case because 1 and e, or 1 to e is all positive, so we don't have to worry about that, but I'll put them there for good measure. And then I integrate x cubed, so that's going to be x to the fourth times 1/4, and evaluate that from 1 to e. All right, and put my value in here, so ln of e minus ln of 1 plus 1/4 e to the fourth minus 1/4 1 to the fourth. Ln of e is 1. Ln of 1 is 0. This is 1/4 e to the fourth minus 1/4. And so we could probably leave it that way, but I would probably see this as 1 minus 1/4, which is 3/4 plus 1/4 e to the fourth. Or if I want to write it as one fraction, it's 3 plus e to the fourth over 4. All right, hopefully that is enough to get you started with your work. Have a good day.